Hey everyone, and welcome back. Today we're going to be doing a demonstration of Maximo visual inspection. We'll start out by talking about some of the challenges our clients were facing that led to the development of MVI. We'll cover what MVI is, and then go into a demonstration specific to life science and manufacturing. Now, to start out, MVI is one of the many tools in the Maximo toolbox. And today we'll focus on MVI, which really is around optimizing the inspection process and ensuring quality production on a manufacturing line. We see quality engineers use MVI every day to ensure quality inspections for accuracy, to help reduce downtime, scrap, rework, and time-consuming inspection processes. So what are some of the challenges that our clients face today? Typically, what I have seen with working with clients in the past is MDI benefiting them really in three ways. Traditionally, I find when working with clients that the process of doing quality inspections on a product or even an asset, it's done in a manual fashion. So you have several engineers, quality engineers, paper and clipboard, standing on the line inspecting the products at different points on the line to ensure that the product is being produced in the correct way. Now, this could be pharmaceutical equipment, med devices, automobiles, and this typically takes up a lot of time and costs that quality engineer could be spending enhancing quality practices or analyzing the data that's coming in. Now, more times than not, we find that during these inspections, human error is frequent. And these exercises where engineers may miss a defect that could have been caught. This can lead to rework costs, scrap, even compliance issues. I'll talk about two use cases in a second I worked with in past year or so that highlighted some of these benefits. Now, with visual inspection, quality engineers can now set up stationary cameras on the production line to take pictures and analyze those pictures in real time. If a defect is detected, an alert goes out in the form of a work order, service request, text message, whatever alert that the team and supervisors set up within their Maximo environment is what they get notified with, or even a notification on the app as well. So this is to allow maintenance to be done in a corrective fashion to keep that quality up to the highest standard. Now, the next question we want to address as part of this demonstration is, what is MBI? So the underlying technology to it's really been around for 30 plus years, but it's now being adopted widely because of how easily we've made it for consumers to configure and apply. This uses deep learning, neural network-based models, which simulate how humans learn to analyze images of the production line to look for defects. We train the machine learning model based off of the images of products in good condition, and then we train it with images that are in poor condition. The more images that it's trained on, the more accurate it becomes. And it really just takes 4 steps to get up and running. Step 1, take pictures of products that are in good, poor condition on the line. Step 2 is to use Maximo to label those images as either good or bad condition. Step 3, choose the model you want. Step 4, set up your camera, begin the inspections. So what's the benefit of this? A large manufacturer that I had the pleasure of working with in the past saved somewhere around 1.8 million in savings. This includes rework costs, scrap, productivity improvements, ensuring that they were within compliance. Now, MVI helped them catch miss builds at the time of creation and not after the build has been completed. Now, this was huge for this particular client in being able to catch those miss builds and defects at the point in which it was created. And it's worth noting as well, within the first month of the pilot that we did, where we put 18 iPhones running MVI, the MVI model, on different parts of the line, where they were running different models to look for defects across the assembly, paint, electrical, welding, exterior. We caught 32 misbuilds within the first month of the pilot, which saved $10,000 a month for this company. Now, this is discrete manufacturing. I know at the beginning of this, I mentioned we're going to really focus on how this applies to life sciences. Typically, life sciences and pharma is more of a process manufacturing. A great example where we did that as well was down in Charlotte, where where I did some work at Sugar Creek Brewery. Now, we installed MBI on a Lenovo laptop connected to an IP camera. So a little bit different setup than what we did at the automotive company. And we used that to identify on the bottling line if the bottles were being overfilled or underfilled. Now, each of those bottles, typically you want to have around 12 ounces of beer in each bottle. And so what we did was we took images of each, and if the machine learning model, MBI, showed that the bottle was overfilled or underfilled, it would send a message to the controller to change the pressure of injecting beer into the bottles to fix the issue. They went from having 3 brewmasters standing around the inspection to just 1. And that was to analyze the data to remove any bottles that failed the inspection and then put those empty bottles back on the line. The other 2 went to help out with other tasks, such as helping out with distribution of the beer, checking on the status of the bright tanks, fermentation tanks, and working on other business critical tasks within the brewery, saving them $30,000 a month in wasted beer. So for this demonstration, I'm going to really show you 3 things here. And this is just an example of if you want to get started with MBI, some of the hardware that we use typically for it. As I mentioned before, it runs on iPhone. I'll show you some of the models that you can run on iPhone in a little bit. And part of my demonstration, I'll show you what that looks like. So again, for demonstration, I'm showing you 3 things today. How quality engineers can leverage MBI on the production floor. I'll then show you how quality engineers can actually set up MBI and build a model with no data science experience. And then lastly, what this looks like from a work order service request perspective for a supervisor to then assess the defect and Maximo manage and take action. So with that, let's put on the hat of a quality engineer for this demonstration. And as I mentioned before, quality engineers are typically responsible for ensuring the quality of products coming off the production line. And they are challenged in ensuring that every product is of highest quality. Now, oftentimes quality is affected by human error or machines not performing well. And this can cause the products to be defective, leading to lost revenue, customer complaints, and if severe enough, even downtime of the plant. So quality engineers need a way to ensure products coming off the line are of the highest quality and have 0 defects. This is where MBI comes in. So the first thing we're going to do is open up the MBI app on your mobile device. MBI can run really anywhere, any mobile device that can run Core ML. So really, we just have to look if you're using other devices, just see if it can run Core ML. And if it can, you can download the app on any app store and get going. So once I've downloaded the app, which again, you'll find on the App Store, let's open it up real quick, type in, just do this real quick just to show you, and there it is. So once the app is downloaded from the App Store, you're just going to open up the app. And so as a quality engineer, I have set up on my this is an iPad on the production line, and this is going to be a stationary camera. And as you can see here, we already have 1 inspection on the far left. It's the Princeton site inspection line 1 that we have this camera set up in a stationary fashion. Now we can configure this to take pictures in real time. And then the way that I've set this up for this demonstration is if, as a quality engineer, as these pictures are being taken, if there's any issues, it's going to send a service request to Maximo. So as a quality engineer, we have this set up on the line, and we're going to go ahead and start the process of taking images. Now, as I mentioned before, this can be done in an automatic fashion where we're taking pictures at certain intervals. And this just is a great way to show you how this would actually run on a production line. So as a quality engineer, the camera on the production line has taken an image and classified the product as either good, missing, or defective condition. Now, as a quality engineer, this is what I set up within MVI on my desktop to look for images of good condition of our product, missing, and defective. And here we can see there's an obvious defect within this image where we have, if you look at that B1 on the top right hand corner, it's missing a pill that it should have. So with that, let's go ahead and take another picture. Say the production line keeps moving forward and we take an image, and here we caught a different defect, and it is of this model is classifying that top right hand corner where it's obvious that something happened to this as part of this product on the production line. It's classified as defective. And that's really the simplicity of MVI. So we set up the model, we've deployed it, and the stationary camera is taking images every 10 seconds in order to, and let's go ahead and add this. Perfect. So as these images are taken, it's going to store these photos back into the MVI model to further train the models. Again, as I mentioned before, the more images and training that this model has, the more powerful it's going to be. And here we can see all the images we've taken so far today did fail the inspection, and we can see some of the other images that we have as well. Now that MVI has caught on the production line a defect, it automatically created a service request in Maximo. And that's what we're going to see a little bit later on. I'm not going to go too much into settings here, but as part of MVI, you have full control of how often this captures images. You have Twilio settings for sending your quality engineers text messages. Image metadata. This is oftentimes used in energy and utility clients where they're taking drone images and they need the GPS coordinates to tie back to assets in Maximo. There's a lot that you can do with this tool as a quality engineer as far as configuration. But with that, we've captured a defect on the production line. Let's go ahead and switch over to Maximo. So as I mentioned before, there are 4 steps in order to create a model. We've seen as a quality engineer how I would leverage MVI on a production site. Now, what does it take for a quality engineer to actually get one of these models up and running? That's what we're going to explore in this next part. And it's really as simple as 4 steps. You create a data set, that is, we collect images for training. We prepare the data, which is labeling the images as good condition or poor condition. You choose which model to run, and there's complete descriptions of each model, so even a quality engineer can fully understand what each model does. And then all you do is click a button, deploy, and you're good to go. You can connect it to your iPhone. You can download it to a local machine and connect that to a camera, and you're good to go. So let's go ahead and get started. So as a quality engineer, once I open up Maximo Visual Inspection, I'm going to see all the different data sets I have. Data sets really just means a collection of photos. And those photos, we're going to go ahead and teach the model what is a photo in good condition and what is not. And this is going to allow the model to understand how to detect this on the production line. So as a quality engineer, let's go ahead and create a new data set. We're going to call this test. Once that data set's corrected, we need to add photos. I'm going to add 2 photos just for the purpose of showing everyone watching this video how this process is done. The next step of this process is to go ahead and label our photos. So we're already on step 2 as a quality engineer. We've uploaded the photos. Now we got to label them. Labeling them allows the machine learning model to understand what is defective and what is not. So let's go ahead and create labels. So I'm going to add a label that says good condition. We're going to say, in the case that there's something missing that is in poor conditioning, we're going to include that. And then defective. So we can classify objects in this photo as either missing, defective, or in good condition. And the most simple part of MBI is the training. And all you have to do is click this little magic bounding box and say, this is in good condition, or this is in bad condition. And it's simply by just clicking here. So here we have a label for defective, which is going to teach the model this is defective. And then this one's in good condition. So the rest of them are in good condition. So let's just go ahead and mark these up. Best practices for this as you're training the model, and I'll show you an example of this in a second, is making sure you get the whole, to make this most accurate, make sure that you get the entire area of the good or poor condition. And one of the best practices I see as well, let's go ahead and label this defect, especially in this image where you have like a certain area of the actual product that is defective. We're going to double bound box that. So it knows, okay, this in total is defective, but this area here is really where. So showing this double bounding box is really going to get you farther when training those models. So get you a more accurate model. So there's some best practices when going about this, but it just takes time and using the tool to learn. So here we're going to go ahead and label the others good condition. Once we're done with this, we're going to go ahead and create our model. And again, it's as simple as that. The reason why these type of technologies are being adopted so quickly now is because of how easy it is to use. So now we've labeled all of our images. Best practice is really to have at least 25 images, in my experience, of each defect. So we had 2 defects that we labeled, missing and defective. So having at least 25 images of that, as well as labeled, will give you a good amount of accuracy for training these models. And then I typically recommend clients having at least 100 to 250 images in total that have gone through this labeling process. It's a little time consuming, but once the model is created and you have it on the production floor, you're good to go. So let's go ahead and begin to train this model. And I'm going to walk you through the 3 different types of training MBI can do. There's image classification, which essentially you teach it what's in this image. So here, this image is of a lion. So that's what the result would be. Now, what's important to us is object detection, because this tells us, okay, here is a refrigerator, here's a microwave, here's what's actually in the image, where image classification just tells you what that image is of. This actually tells you what's in the image. And this is what we want, especially for looking at defects on the production line. And then lastly, action detection. So if you can also process video. So if you wanted to see or classify certain actions within a video, you can do that as well. So with image classification, there's only one model. With object detection, you can have a couple choices here. And just to give you an idea of what the differences are between this, we have faster RCNN. This uses TensorFlow, which is something Google created that has additional object detection already built in. So this includes publicly available object detection to classify people, cats, dogs, other images, objects, and images. Then we have Tiny YOLO. YOLO stands for you only look once. Quick, dirty, made for speed, can run on an iPhone, but typically is less accurate. This is the one that I typically recommend for running on a Core ML enabled device like an iPhone, iPad, and it's this YOLO V3 model. It takes a little bit longer to train. The model that I showed in today's demonstration took about 6 hours to run. Again, I was hands off during that time as a quality engineer. You just have to wait till it's done processing and training. The next model, Detectron, is best for when you're labeling those objects with irregular shapes. I didn't show this in this demonstration, but there's a way, instead of using a bounding box, you can use something called a polygon, which is where instead of labeling objects with that little square bounding box, you're gonna be able to label it using irregular shapes, if that makes sense. And if there's any questions about this, I can always make another video. High resolution, great for clients where you're looking at defects with very high resolution, very small objects that you may not be able to see well with the human eye. This is where you would use high resolution images, but for this demonstration, we're really going to want to use YOLO V3. And really the last step as a quality engineer I'm going to attack is just to train the model. Now, the training for the model, once it's complete, and all I have to do is click the train button. Once it's complete, it's going to show up here. And it's going to have the type of model you created, the accuracy, which I'll explain in a second, what data set, when it was created, and if it's deployed or not. So let's go ahead and click our model to see what we've created. So now that it's done training, again, it's going to take a couple hours for the model to train. It's going to show the accuracy of the model along with different hyperparameters. I'm not going to go through all of this, but what's really important as a quality engineer is if this is accurate or not. This accuracy score comes from the model training on a data set and then testing. Now, what that means is the model itself is programmed to take 80% of the images you gave it to train, and then 20% of the images to test out how accurate the model is. Did it get now you have to remember these images are labeled, so the model can train and then test on the images to understand, okay, without looking at the label, did I classify this right? And if it did, and the label, it classified it identical to the label it was given originally, then it knows how accurate the model is. So very similar to how we learned growing up as a kid. Say that you have images of a piece of broccoli and you have images of a tree. Both have stems, both have a canopy, and you're trying to teach this child, which is how I think of AI, the difference between the two. So you give them 100 images and with labels at the bottom that say this is broccoli, this is a tree. You have the child goes through 80 of those images, sees the broccoli, sees the label at the bottom, then sees a tree, the label at the bottom. The child trains on that, and then it goes over to that last 20 images, and without being shown the label, the child has to guess if it is a broccoli or a tree. Same thing with this model. In each iteration of this, you see it's gone through 4,000 iterations. It's gone through quite a bit of training. It's done this 4,000 times. This is what this type of information means to a quality engineer. And down below, you can see the precision in which it's been able to classify as good condition, defective, and missing. So that was a long-winded description of how this model is running in the background. In layman's terms, once you have this model created and you're happy with the results of it, we're going to go ahead and click this deploy button. As you can see, it's already deployed. And this will allow us to pull that model down into the iPad, which I showed earlier. So we have that model, it's deployed, it's ready to go. The last thing we just need to do is create a project, which will have the data set, the model, and we're good to go. We'll open up the iPad, connect to it, and really that is Maximo visual inspection in 10 minutes. So there's one last thing I want to show. So we're going to switch hats here to the role of a supervisor because there's been a defect on the line that we caught initially in this demonstration. So we should see a corresponding service request created for a supervisor to begin taking corrective action. And here we see that, yes, there was a production defect. This is a high priority. We have a defect on the production line that as a supervisor, I want to assess. We can see where the location is, some of the metadata that came from the service request generated by the iPad app. And what's important here for me as a supervisor is I can also view attachments. And let's go ahead and open this up and see exactly what type of defect occurred. And here we can see the image and the defect from that visual inspection. And from there, as a supervisor, I can then go ahead and approve a work order for corrective action to be done. So with that, that was a quick and dirty demonstration of Maximo visual inspection. Please let me know in the comments if there's anything else I can show you guys. If there's any questions, I'll also include my email so you can email me if needed. But with that, thanks for joining, and look forward to showing you guys future demonstrations.